In today's note, we're going to be looking at confidence intervals. And our goal of today is to be able to describe the margin of error and confidence level of a normally distributed population. So when you do not know the population mean, you can determine confidence intervals. And what confidence intervals are, that they're a range of values in which mu, or the mean of the population, is likely to fall. And these intervals use the margin of error, or E. These intervals are centered on the sample mean, x, and their widths depend on the confidence level. So how big the width of our interval are, the range of values, depends on how confident we want to be that the mean is within that. So for example, if I have a 95% confidence interval, it has a 95% probability of including the mean. So for my formula, I have that mu, or the population mean, is greater than the sample mean minus the margin of error, but less than the sample mean plus the margin of error. So again, remember x bar is the sample mean. Our E values refer to the margin of error. And we can determine margin of error, or E again, two ways. Our first way, it would be the z-score times the square root of p times 1 minus p divided by n, and p refers to the probability or proportion of number of successes. So we've seen p before and other things like p and q for binomial distributions. So p is just the probability of success, or the proportion of number of successes. And then z refers to our z-score, and n refers to the total number of data or items. And refers to, again, we said total number of data. The second formula that we could be using is E is equal to the z-score times the standard deviation divided by the total number of data, or the square root of the total number of data. So we have a z-score, we have our standard deviation, and again our n, total number of data. So what does this basically look like? Well, this is what the margin of error or confidence intervals look like. I have my sample mean in the middle, and I have my margin of error and my upper and lower limit. So it's basically saying I have that lower limit that we talked about, the x bar minus the mean, x bar minus the margin of error. And so the mean is in the middle of these two limits. Our confidence or confidence levels and the z-scores, so these, depending on how confident I want to be in having my mean within that margin of error, I would use these confidence levels. So 90% confident that it's going to fall within the range of values, 95% confident, and 99% confident. And these are the z-scores that are associated with that level of confidence that we would be using in those formulas. So if we walk through one example, I'm looking at a paint manufacturer that wants to use the slogan, dries in T minutes. They used 20 equal test areas and found the mean drying time to be 75.4 minutes with a standard deviation of 10.5 minutes. Determine the 95% confidence intervals for the mean drying time, what would be a reasonable t-value? So some things to take out of this equation. We have 20 equal tests. So this is the total number of data. I have the 75.4 minutes, which is my x bar, or the sample mean. I have my standard deviation, the 10.5, and I know that I'm looking for the 95% confidence intervals. So that 95% will tell me the z-score. So if I'm trying to find my formula or my intervals, where I'm going to have x bar minus the margin of error, then my mu, or the mean, x bar plus the margin of error, I need to first figure out my margin of error. So my e value, in this case, because I'm given z-scores and I'm given standard deviations, my margin of error formula is going to be z times the square, or the standard deviation, divided by the square root of n. So e, my z-score, because it's 95%, my z-score, going back to the table on the last page, will be 1.96. Standard deviation is 10.5 divided by the square root of 20, or the total number of data points. And this tells me that e is equal to 4.6. So I can take this e value now and plug this into my confidence intervals. So x bar was the mean, so 75.4 minus 4.6, my margin of error, and then 75.4 plus the margin of error, or plus 4.6, and I get 70.8 and 80. So what does this all mean? What we can say then is, therefore, we can be 95% confident that the paint will dry between 70.8 minutes to 80 minutes. So if we're trying to answer the question of what would be a reasonable value for the time, you could pick anything within this, in this range. So looking at the other formula that we had, we can also look at the proportion or percentage of population that has a particular opinion or characteristic. And this proportion is considered P, or the probability of success in the binomial distribution. And when data is expressed in terms of proportions, the confidence interval formula becomes, instead of the mean, it's the probability minus E and the probability plus E. So these here would be my confidence interval. So very similar to what we just did in the last note, these would be my confidence intervals. So for example, the DSBN surveyed 70 parents on the question, should uniforms be worn at school? 28% answered yes, and I want to determine the 90% confidence intervals for the proportion of DSBN parents who want uniforms. So if I take a look at my question, there's some key information. The 70 is my n, the total number of data values. The percent or proportion that answered yes is going to be my p-value, which is to 28%, or 0.28. And I'm looking for 90% confidence intervals. So that tells me what z-score I'm using. So because I'm dealing with a proportion or percent, I'm looking for my margin of error using the formula p times the square root of p, 1 minus p divided by n, sorry, not p, z score times the square root of p minus, or times 1 minus p divided by n. So my z score from the table for a 90% confidence interval is 1.645 times the square root of p, or 0.28, times 1 minus 0.28 divided by 70, or the number of parents. Okay, E is equal to 1.645 times the square root of 0.00288, and I get an E, or a margin of error, is equal to 0.09. So I know my margin of error is 0.09. So now I can take that and plug that back into my formula for the confidence interval, which was P minus the margin of error and P plus the margin of error. So I have P, which is 0.28, minus 0.09, and 0.28 plus 0.09. And when I simplify, I get 0.19 and 0.37. So therefore, we are 90% confident that between 19 and 37% of parents will say yes to the uniforms. So the key thing in this note was being able to determine the margin of error using certain confidence levels, and then using those confidence levels to determine roughly where the average would be, or what range of values would include the mean.